So see, if we find the value of dy by dx, or if we find the f dash of x, so what is the meaning of that? The meaning of that is slope of tangent. We all know that dy by dx is nothing but slope of tangent. Dy by dx is simply what? Slope of tangent. Now see, if I taking here that dy by dx, or let us suppose to be f dash x, this is equal to be 0. Now we are solving the value of x, for which dy by dx or f dash x, this is equal to be 0. Now see here, it means we are solving for the point where slope is 0. We are finding the value of x where the slope of tangent is 0. Okay. Now in the graph, tell me what are the point where slope is 0, means where tangent is parallel to x-axis, because we know the x-axis having slope 0, means this point. You can see this is the point. If you plot the tangent here, so here tangent will be parallel to x-axis. So this type of horizontal tangent will be formed here. At this point also, the horizontal tangent will be formed. At this point also, what will be there? The horizontal tangent will be formed. At this point also, if you plot the tangent, so at this point also the horizontal tangent will be formed. At this point also the horizontal tangent will be formed. Okay, means when we solve this equation, so we will get the value of x where tangent is parallel to x-axis. So we will get this point. Let us suppose we are getting the point something x1, we are getting the point something x2, then let us suppose here we named as supposed to be x3, and this is the point here we have taken as x4, and let us suppose here we have taken as x5. So these are the point where tangent is parallel to x-axis. Now see here, in this point there is one speciality. What is the speciality? If we are talking about this point, so this point is at the highest in their neighbor. Means if we are talking about this point here, let us suppose this point, so this is the point below this. If we move forward also, so other point will also be below this. Means this is the point that is having the highest value in their neighborhood. Means अपने आसपास में, अपने पड़ोसी में. So this point having the highest value in their neighborhood, so we will call this point as point of local maxima. We will call this point a point of local maxima. क्योंकि अपने local में this having the maximum value. Similarly, if I talking about this point number x2, you can see if you go back, means means in the left hand side, you will get the point in the upper side of this. If you go in the right also, you are getting the point upper side of this. Means this is the point that is the belowest point in their neighborhood. So we will call this point as what? We will call this point as point of minima. This is the point of minima, or point of local minima is the more correct word. Point of local minima. This is the point of local minima. Similarly, you can see this point. This point again is the highest in their neighborhood. So we can say this is the point of local maxima. This is the point of what? Local maxima. So now hopefully you get the concept now. What is the local maxima and what is the local minima? So this is also what is this point? So this is the point of local minima, and what is this point? So this is the point of local maxima. So means the local maxima and local minima are the point where dy by dx is 0, because at this point, so we can find the point of local maxima and local minima. How? By that dy by dx is 0. But how to differentiate which is local maxima and which is local minima? Because we cannot differentiate it. So for that, what we can take here, see, there are two methods. One is the double differentiation method. One is the double differentiation method, and one is the single derivative method. You can see here, all of you, that if you are moving from this side, so what is the dy by dx here? So here the graph is increasing graph. The graph is increasing, means graph goes on increasing. So if graph is increasing, so here slope will be positive, or you can say dy by dx will be positive. So after, if dy by dx is positive and then we are getting the dy by dx is 0, that will be the point of maxima. In this side you can see, if we're talking about this region, so in this region our dy by dx is what? So dy by dx will be negative in this region, because this is a decreasing graph. You can see when we are goes on increasing the value of x, but graph is decreasing. So this is a decreasing graph. So if something is decreasing, so after decreasing you will get the minimum value. So if graph is decreasing, so after decreasing graph you will get the minimum value. But if graph is increasing mode, so after this you will get the maximum value. Means we can check the sign of dy by dx, where it is positive and where it is negative. So after positive sign we will get the maximum value, after negative sign we will get the minimum value. So this is the one method to solve this. The double differentiation method I will discuss later, but first we have to learn this. Means when we are finding the dy by dx equal to 0, so this we can say this is the critical point. These are the critical point where graph may be maxima or minima. So that we have to check now, which is the maximum or which is the minimum. So here we can do, so we can solve. So after solving this equation, we get the value of x. So the value of x is called as point of extrema. Extrema means either maxima or minima. Extrema point. Extrema means both. Inside its maxima and minima both are there. So extrema means what actually? The word extrema means maxima or minima. The meaning of extrema is maxima or minima here. Okay, fine. Means when we are solving the dy by dx, so we will get the point of maxima or we will get the point of minima. Okay. Now if we have to find which is the point of maxima and which is the point of minima, for that we have to check. So here we can write this point also, then we come to the question. So after dy by dx is greater than 0, means if dy by dx is greater than 0, if dy by dx is greater than 0, and then after this the point will be point of maxima or point of local maxima. It means in a graph there may be more than one maxima, because we are talking about the local maxima, not complete maxima, local maxima. So there may be more than one maxima. Similarly, after dy by dx less than 0, let us suppose if we have less than 0, after this the point will be point of local minima. This is the point of local minima. So let me show you in the graph. So what I am saying here, before that these things you can show. So you know actually, so if I am plotting the graph like this, let us suppose in this way or in this way. So this side what happening here, this side our dy by dx is greater than 0. So after dy by dx is greater than 0, we are getting any point. So this is the point of what? Local maxima. This is the point of local maxima. And if this side we are talking about, so this is here dy by dx is less than 0, that is the negative, means graph is decreasing. So after decreasing the point you will get, that is the point of local minima. So this way we can find the local maxima and local minima. This is the point of local maxima and local minima, right? This is not the value. For value you have to put this point in your given function, then you will get the maxima value or minima value. So now let us come to the, so these things we have discussed, and at this point what happened? At this point the dy by dx will be equal to 0. At the maxima or minima point, dy by dx equal to 0 also. If you find at this point, so dy by dx is equal to what here? Equal to 0. So these things we have discussed. So fine. So I think now we can start solving the question. So we can solve the question now. So let me take first question number 1. Question number 1, come to the exercise 6.5. All of you come to the exercise 6.5 and let us start solving the question now. So exercise 6.5, question number 1. Let us, so hopefully any question here you can ask first. If any one of you have any question in these things, you can ask. Any question here? No? So come to the exercise question. Let me take the first question. Exercise, we are doing exercise 6.5. Exercise 6.5. 6.5, question number 1. See, question number 1. It says find the maximum and minimum value. It's talking about the maximum and minimum value. Question is find maximum and minimum value. Minimum value, okay, of the following function given by. Of the following function. So following function, let me take the first one here, how we have to do. So first question is given to us as f of x is equal to what? 2x minus 1 whole square plus 3. Now see, this is the graph is given to us, this is the function we are given to us. So if you go to increasing the value of x, so you will get the higher and higher value. So what are the highest value that is possible here? That we want to solve. So how we can get the maximum value? So you know, for the maximum minima, the first case is you have to solve the dy by dx and take it equal to 0. So here we can write, we know for maxima or minima, for maxima or minima, we have to take f dash x and this should be equal to 0. This is the first step. That if you want to find the maximum minima, the first step is what? You have to find the f dash x and take it equal to 0 and solve it. So if we take f dash of x, you all know the differentiation. How? Firstly we will do the differentiation of its power. So it will be 2 into 2x minus 1. So differentiation of power done. Going inside, differentiation of 2x is 2 and differentiation of 1 is 0 and it is also 0. So it is getting to be equal to what? 0. Okay, fine. So now see, what is the value of x we are getting here? That is 2x minus 1 equal to 0. This implies the value of x is equal to 1 by 2. So what we are getting? We are getting the value of x equal to 1 by 2. Fine. Now we have to check, this is x is equal to 1 by 2 is the point of maxima or point of minima. Okay. So see, if we plot on the number line, so this is our minus infinity and this side we have plus infinity. So this is the point half. Okay. And what is the our given function f dash x? F dash x is equal to something, you can write in this way. This is 4 into 2x minus 1. Now you can see, if you take any value greater than half, let us suppose to be 2. If we are putting here 2, so 2 into 2, 4 minus 1 is 3, that is positive value. Means for this side, all the value we will get a positive sign. So alternate sign, you know the baby curve method I teach you in the class 11th also, I think, if you remember. So sign will be alternately changed. So this region it will come to be negative. Means this is the sign of f dash x. This is the sign of what? This is the sign of f dash of x. Now tell me, this x is equal to half is the point of maxima or minima? Tell me. X is equal to half is the point of maxima or minima? This is the sign of dy by dx. This is what we got here. This is the sign of dy by dx. Means dy by dx, this side is negative, 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 then 0. Then dy by dx becomes positive. So tell me, this x is equal to half is point of maxima or point of minima? Means local maxima or local minima? Tell me. What is this? Maxima. Okay. Okay. What is that? This is the point of local maxima or minima? No. Garima, what do you think? Minima. Okay. Nihar, tell quickly. No problem. It's maybe wrong. We are here learning. It's a learning process. Minima. Okay, fine. Good. See. Let us see now. So this is the graph. Means here this side dy by dx is negative. So dy by dx is negative means what? The graph is decreasing. So graph is decreasing means what? It will be going like that. This is the graph, decreasing graph. This is the dy by dx. This side actually the graph is negative. That is the f dash x is negative. Graph is decreasing. Now after that it is 0. Means at this point it will be like that and then positive. So it will be going this way. So this is the point half, right? So I told you if your this side, if dy by dx is less than 0. So after negative you will get the point of minima. You can say this is the minimum value. This is the lowest value. So this is the point of minima here. Point of minima. So this is what actually x is equal to half is the point of minima. Point of minima. Right? Means simply you have to check the left hand side of point. Left hand side. So this is the point. Its left hand side. If it is negative, after that this will be what? This will be the point of minima. But if this side is positive, means the graph is increasing. So after increasing you will get the maximum value. But if graph is decreasing the left hand side, so after that it will give the minimum value. It's clear, Sujipta? Got it or not? It's okay. Okay, fine. So now means what we are getting this. So this is the point of what? So this is the point of local minima here. So this is the point of local minima. This implies, here we can write, this implies x is equal to half is point of local minima. This is the point of local minima. This is the point of local minima. So now find the minimum value. Easily f minimum value how you can get. So if you put this in your function. So what is the minimum value? If you put half in your function. Where is your function? This is your function. That is the 2x minus 1 whole square plus 3. So if you put here, that is half, it will be 0. 0 plus 3, this will be 3 only. So what is the minimum value of this function? Here minimum value is 3. You can ask what is the maximum value, sir? So maximum value will not exist because it will going up and up. So the maximum value is not finite. It will be going up and up. So maximum value is here not possible. Got it? Coming to question number 2. Question number 2. Can you solve this? Question number 2. You can see here f of x is equal to 9x square plus 12x plus 2. You have to find maxima minima. You do the same. So here you can write we know for maxima and minima. We know for maxima or minima, not and. For maxima or minima, what we have to do? We have to find simply f dash x. Do this. This here you are getting, that is 18x and then plus 12 and take it equal to 0 and find the value of x. So what is the x you are getting? Minus 12 upon 18. So 6 to the 12 and 6 to the 18, that is minus 2 by 3. Now we have to check ki minus 2 by 3 is the point of maxima or point of minima. This we need to check. Okay. So for that we need to check the sign of dy by dx. So this is our minus infinity. This is plus infinity. This is the point minus 2 by 3. So now check the sign of f dash x. So with the help of this we can find the maxima or minima. So if we are taking any value from this side, what we are getting here? If you taking any value from this side, so what we are getting here? This side the value will be, let us put here. So this is your where it is your f dash x. So f dash x here we have 18x plus 12, right? So if you take any value from this side, you will get a positive. Let us suppose put 10. So it is positive, means this side it is positive, this side negative. So what value we are getting? So what is this? This is the x is equal to minus 2 by 3 means what? This is the point of minima. Got it or not? Means again this side negative. So this is the point of minima. Point of minimum. Got it? So what is the minimum value? If I'm talking about the minimum value, so you have to put this value in your function here. See, very important. So if, because question talking about the minimum value, so you have to put this into the function, that is 9 into minus 2 by 3 whole square plus 12 into minus 2 by 3 and then plus 2. If you put it here, what you are getting? 9 into 4 by 9, and here you are getting as, you can cancel this 4 times. So this will be here minus 8 and then plus 2. So this 9 to 9 cancel, and this is 6. 6 minus 8 is minus 2. So minimum value of this function is what here? Minus 2. So this function cannot be less than minus 2. The minimum value possible is minus 2. It is not less than that. Got it or not? It's clear all of you? Okay. Okay, Nihar got it? So question number 4 I am leaving for you. This question you have to try by yourself. Now coming to the question number 2. So first ka, third and fourth you have to do by yourself, and then time is here or time up? We have time. So see next here you can see next question here, question number 2. So if you see question number 2, so question is find the maxima and minima value if any of the following function. Okay, the same question is here. So find maxima and minima value. So find maxima and minima value, minima if any possible of following function, So I think question number, okay, let me show you the question number this one. So this is mod is involved here. Mod f of x is equal to what here? This is x plus 2 mod minus 1. Now we want to find the maxima value and minima value. So how we can find its maximum value? See, so for maximum value, firstly we need to open this mod. Our first task, or you can do this by graph also. So if you very good in the graph, so the various questions you can do with the help of graph. See here, this is fx is equal to x minus 2 mod. So let me first open the mod. So if x is greater than equal to 2, sorry, greater than equal to minus 2. Let us put a case when x is greater than equal to minus 2. So if x is greater than equal to minus 2, then you know the fact that the mod will be positive here, right? So if mod is positive, so we can open this very simply. We can open this like that. This is x plus 2 minus 1. So we have to check that, we have to take the two cases. Now see what is here. This is x plus 1 equal to, this is this is the fx is equal to x plus 1. So what is the value of f dash of x? So f dash of x is simply here 0. F dash of x is what here? F dash of x is here 1, right? So this is the differentiation of this part is here 1. Okay. So this is the part here. Now we need to check कि f dash of x is equal to 1 we are getting. So what is this actually? Means it is positive, means it is increasing, right? Because f dash of x is positive. So for all the value x greater than because what you want actually, you have to take this part equal to be 0. Sorry, we have to solve f dash of x is equal to 0. F dash of x is equal to what? F dash of x is equal to 0. But you can see this is not 0. Here it is goes on increasing. Okay, let me check for the negative side. If we take here the negative side, so this is our fx. If we take our x is less than equal to -2, let us suppose x is something -3. So in that case it will open with the minus sign. It will be here minus of x plus 2 and then it will be here -1. So what is this value? Minus x, -2, -1. That we are getting -x, -3. This is the value of f of x. But we need to find f dash of x. What is f dash of x? This is here we have now -1. Okay. So you can see here one thing, that this is again not 0. This is again not 0. So now we think here, sir, it is here we are not getting the point where f dash of x is 0. Means what? It may be the possible. Let us suppose this type of graph is also possible. Let us suppose the graph is like this. It's going here in this way, and in this point, suppose it's taking the sharp corner. It's taking the sharp corner like that in this way. So actually the point where sharp corner is forming, so that is the not differentiable point. So this is the point here we are getting. This is the non-differentiable point. This is our x, and this is here we have y. So this is the non-differentiable point. So if point is non-differentiable, so how it's come to be here 0 of that? Means it is the possibility that this is the non-differentiable point. So for that, what you need to do, you can plot here graph. You can plot here the graph, right? So if we plot the graph, here or here, what is the graph of this x plus 2 and then -1? So if you remember the transformation of graph, or you can see one thing also here, that this is the mod. This question we can do by analyzing portion only. This is the case. So this is the mod. So what is the minimum value of mod? We want minimum. So how we can get f minimum here? F minimum we will get if this quantity is minimum and this quantity is maximum, because the subtracting part is maximum and the term from which we are subtracting, if it is minimum, then we will get the minimum value. For example, let us suppose here if you want to subtract, so what is the minimum value of this? So its mod is minimum to minimum 0. It is not less than 1. Sorry, it is not less than 0. So what is the minimum value of that? So minimum value of that is 0. And what is the maximum subtracting part? So because of subtracting part is 1, so it is fixed number. It is a constant number. So the minimum value is what here? -1. So if we plot the graph here, so the minimum value of this is -1 actually. -1 is the minimum value. Where it will be? It will be at the point x equal to -2. Right? If you try to plot its graph, I am showing the graph also. So this is the graph here. F of x is equal to x plus 2 mod -1. So if you plot the graph here, you will get the graph like this. So it will be here -2, means this point is -2. Okay. So let me show you the transformation of graph. So this is the graph of what? If I am plotting this graph, let me go down. More space required. See, if I am plotting the graph of, here, this is x. This is x here, x dash here, y and y dash. What is the here the vertex point? This is -2. Means it is the graph will be 0 here. This is the graph will be going like this. So this is the graph of what? So this is the graph of x plus 2 mod. But we have to subtract -1. It means what? We have to decrease this graph by -1. So let us suppose this is the point -1, means this graph now come here. The same graph will be there, but we have to put here. So this graph will be what actually? And if you put here x is equal to 0, so x is equal to 0 means what? Where it's cutting the y axis, so it will be at the point it will be at the point 1, means the graph will go like this. And if we are putting y0, so here we are getting the point of what? X is equal to, this will be I think 1/2. Okay, so it will passing from here. The graph will go here, 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 like this, in this way. It's not passing from the origin. So this is the graph. This will be the graph of this. You can see this is the graph of what? So this is the graph of x plus 2 mod and -1. So this is the graph of our fx. This is the graph of our fx. Means what is the minimum value? You can see the minimum value is -1. So graph is always above the -1. So what is the minimum value of graph? So minimum value of graph is -1. Now you can see here, because this is a sharp corner is forming. That's why if we solve the value, this is the point what? This is the point x is equal to -2. This is the point x is equal to -2. So that's why if you have taken the x is less than equal to -2, you are getting that differentiation part is -1. Means the slope of this line is -1. The slope of this line is what? Here f dash x is what? Here -1. But when you are going right hand side, means greater than 2, so this is the slope now. The slope is changing. So what is the slope of this? Here slope is 1. And if you are talking about this point, so this is a non-differentiable point. What is this actually? So this is the non-differentiable point. Non-differentiable point. That's why non-differentiable point. Means if we are getting this type of questions in which the mod is involved, so for that what we need to check? We need to check there the point of there. This is also the point of non-differentiability. So you can get the critical point. So by this you can solve this question. So hopefully you are getting some concept here. Is it okay? Getting it or not? How I am saying here? By the common sense also you can solve this. This is the x plus 2 mod -1. So you can see here what is the maximum value, sir? You can ask, sir, what is the maximum value? So maximum value is here does not exist. That is infinity. Because see, this is the mod. As you goes on increasing the value of x, it will be increasing. But subtracting part is constant. So maximum value is not fixed. Right? Maximum value is here not fixed. If let us suppose you are putting x is equal to 1 lakh, so value is increasing. If someone putting x is equal to 1 crore, value is all again increasing. Someone put x is equal to 10 crore, value is again increasing. So as you are going on increasing of value of x, it will be increasing. But what about the minimum? Because it is minimum use of